this lesson. I'm teacher Agnes, and today we are going to be discussing about volume and capacity. Volume and capacity. So we're going to begin with volume, and then later on we're going to find out what is the relationship between volume and capacity. So to begin with, when we talk about volume, we refer to the amount of space occupied by matter or an object. If you look at this marker, it is occupying a particular space which is different from the space being occupied by this pen. So the two are occupying different amounts of spaces. That means that they have different volumes. So between this marker and this pen, which is occupying more space? The marker is occupying more space than the pen. That means that the volume of this pen is bigger than the volume of this pen. Alright? The volume of the marker is larger than the volume of the pen because the marker is occupying more space. So when you determine the space occupied by this marker, you must use units to describe that volume. So what is the common unit that is used to describe volume? The SI unit. The SI unit of volume is cubic meter, which is written as meters cubed. That is the SI unit, or the standard unit that is used for volume. But is this the only unit? No, there are other units, and the other two most commonly used units of volume are cubic centimeters, which is written as centimeters cubed, or cubic millimeters, which is written as one is not there, which is written as millimeters cubed. So these three units can be used to describe volume. That means that the three units are related in some way. So how are they related? So to first understand what is a cubic meter, if you have a box, a cube that is 1 meter long, 1 meter wide, and 1 meter high, okay? So this is our cube. This is 1 meter long, 1 meter wide, and 1 meter high. Then we say that the volume of this cube is 1 times 1 times 1, which is equal to 1 meter cubed. So when we talk about 1 meter cubed, we refer to 1 meter times 1 meter times 1 meter. So 1 meter cubed can be broken down into 1 meter times 1 meter times 1 meter. Now I want us to derive the relationship between meters cubed and centimeters cubed. Now 1 meter is equivalent to how many centimeters? 100 centimeters. So times 100 centimeters times 100 centimeters. So if you use centimeters to represent the meter, you will have 100 centimeters times 100 centimeters times 100 centimeters. So we will be able to conclude that this 1 meter cubed will be equal to 100 times 100 times 100 is 1 million centimeters cubed, because this is centimeters times centimeters times centimeters, which makes up centimeters cubed. Now what about in millimeters cubed? Now from length, we learned the relationship between a meter and millimeters. 1 meter is equivalent to 1000 millimeters. So in place where we have 1 meter, this will be equal to 1000 millimeters times another 1000 millimeters times 1000 millimeters. So if you multiply 1000 by 1000 by another 1000, you get 1 billion. So we can conclude that 1 meter cube is equal to 1 billion, is equal to 1 billion millimeters cubed. So the two relationships that you must not forget is that 1 meters cubed is equal to 1 million centimeters cubed, and then 1 meters cubed is equal to 1 billion millimeters cubed. But what is the relationship between centimeters cubed and millimeters cubed? So we have already stated that 1 centimeters cubed is equal to 1 centimeter times 1 centimeter times 1 centimeter. Now, how many millimeters are there in 1 centimeter? In 1 centimeter, we have 10 millimeters times another 10 millimeters times another 10 millimeters. So, if you multiply 10 by 10 by 10, you will obtain 1000 millimeters cubed. So 1 centimeters cubed will be equal to 1000 millimeters cubed. So you need to recall these three relationships so that you are able to convert any units of volume. If you forget, just follow this process that we have used to derive the relationship. So now we're going to attempt some questions involving conversion. We are going to convert starting with 2.8 meters cubed to millimeters cubed. So remember, there is a relationship between meters cubed and millimeters cubed. Now, what you need to ask yourself is, between meters cubed and millimeters cubed, which unit is bigger? You can imagine how long 1 meter is and how small a millimeter is. So 1 meters cubed, or rather meters cubed, is bigger than millimeters cubed. So the bigger unit is the one that you give 1, such that 1 meters cubed will be equal to so many other millimeters cubed, and in this case is 1 billion. So we have just learned that 1 meters cubed is equivalent to 1 millimeters cubed. Now in the question, we have been provided with meters cubed, 2.8 meters cubed. So you write 2.8 on the side with meters cubed. So what about 2.8 meters cubed? How many millimeters cubed will be equivalent to 2.8 meters cubed? So what we do, we cross multiply such that 2.8 multiplies by the 1 billion. So here we have 2.8 meters cubed times 1 billion millimeters cubed, all that over 1 meters cubed. So at this point, you will realize that the meters cubed will cancel out, and the answer that you will get will be in millimeters cubed, which makes a lot of sense because you were supposed to convert meters cubed to millimeters cubed. So 2.8 times 1 billion, 1 0 will move the decimal point forward. So we will have this 28, and then how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 millimeters cubed. So that becomes our answer, and 2.8 meters cubed is equivalent to what we have here, 2 billion 800 million millimeters cubed. So next, we are going to convert 400 centimeters cubed to millimeters cubed. So you need to ask yourself again, between centimeters cubed and millimeters cubed, which one is greater? So centimeters cubed is greater. So we start with 1 centimeters cubed is equal to how many millimeters cubed make 1 centimeters cubed. So we agreed that 1000 millimeters cubed is equal to 1 centimeters cubed. So what about the question has provided us with centimeters cubed? So how many millimeters cubed will be equal to 400,000 centimeters cubed? So you notice that we have written this centimeters cubed on the side with centimeters cubed. So we cross multiply. So we have 400,000 multiplied by 1,000, all that over 1. Now remember, we are looking for millimeters cubed, so our final answer must be in millimeters cubed. So when you multiply this, you will obtain 400 million. Do not forget the units, millimeters cubed. So these are the units you are looking for, and now we can comfortably say that 400,000 centimeters cubed is equal to 400 million millimeters cubed. Then finally, we have 0.0067 meters cubed to centimeters cubed. All right. So now we are comparing meters cubed to centimeters cubed. Again, you ask yourself, between the two units, which one is greater? So meters cubed is greater, so we start with 1 meters cubed. And this will be equal to how many centimeters cubed make up 1 meter cubed? It's 1 million centimeters cubed. So what about 0.0067 meters cubed? How many centimeters cubed will that be equal to? So again, we cross multiply. So 0.0067 times 1 million, then divide by this one. So we have 4 decimal places here. So to eliminate them, we cancel out 4 zeros. So we'll be left with 2 zeros. So this is so this decimal point will move forward 1, 2, 3, 4. So we have 67 times 100, which is equal to 6,700. What were we looking for? We were looking for centimeters cubed. So centimeters cubed. So 0.0067 meters cubed will be equal to 6,700 centimeters cubed. So now we have learned what volume is, the 3 most commonly used units of volume. That means there are others. And we have learned how to convert between the 3 units of volume. Now, like we said, volume refers to the amount of space occupied by an object, and different objects have different shapes, meaning that we have different formulas for calculating the volume occupied by different objects. So now we are going to look at how to calculate the volume of 3 objects. So to get started, we are going to begin by looking at the volume of a cuboid. Do you know what a cuboid is? Have you ever seen a solid that is in the shape of a cuboid? If you look around you, are you able to see anything that is in the shape of a cuboid? As for me, I have a book, and this book is in the shape of a cuboid. So you notice that this book has got 6 faces. This face, which is also equal to this one, the top face, which is equal to the bottom face, and then the 2 side faces, which are also equal. So a cuboid has got 6 faces, and then the opposite faces are equal. The top face is equal to this one, and so on. Opposite faces are equal. Now, the faces that make up a cuboid are rectangular in shape. So you can't have, a 6-faced solid that is made of triangles and call that a cuboid. So for a cuboid, the faces are in the shape of a rectangle. So how do we draw a cuboid? So there are so many ways of drawing a cuboid depending on whether you want it closed or whether you want it open. So as for me, I begin by drawing the rectangle on the top face. You have to make it slanted so that it can take a three-dimensional face or form. Then you drop the height. So we have these two heights, and then we have this one. Then you connect the heights. Alright? There it is. So this is a closed cuboid. Now in this cuboid, there are three dimensions that we must take note of. So the longer side is known as the length. Then this is known as the width. And then this is the height. So this is denoted as L, this is H, and this is W. So if you want to determine the amount of space occupied by this cuboid, you multiply the length by the width by the height. So the formula for calculating volume of a cuboid is equal to length times width times height. So let us assume that the width of our cuboid here is 5 meters, the length is 8 meters, and the height is 3 meters. What would we say is the volume occupied by this cuboid? So we would multiply the length, which is 8 meters, by the width, which is 5 meters, by the height, which is 3 meters. So 8 times 5 is 40. 40 times 3 is equal to 120. Now remember, this is meters times meters times meters. That makes it meters cubed. So whenever you calculate your volume, no matter the shape or the solid you have been given, ensure that you don't forget the units. So the volume of this cuboid would be said to be 120 meters cubed. Now, what if you have been given the volume and maybe the length and the height, and you need to calculate the width? How would you approach that? So we're going to come up with different formulas that you can use to calculate the length, width, and the height. So if you want the length, then you will take the volume, divide by length times width times height. So you realize that these two units here, from this formula, if you want length, you just need to divide this side by width times height and divide with the same on this side. So when you're looking for length, you divide volume by width times height. So what do you think is the formula for calculating the width? So width will be given by volume divided by width is missing from this formula, so we'll have length times height. And then if you want the height, it will be volume over length times the width. Alright, so from this you can either calculate the volume, the width, the length, or the height. So I want us to practice this using a table of figures and then see how we can go about it. So now we are going to practice the three formulas that we have learned that we can use in questions of volume of a cuboid. Now in the first one, we are required to find the volume given that the length is 12, the width is 4, and the height is 8. Alright? So the volume of a cuboid is given by length times width times height. So we have 12 times 4, which gives you what? That gives you 48. And then we have 48 times 6. 48 times 6 will be equal to 8 times 6 is 48. 8 carry 4. 4 times 6 is 24 plus 4, which is 28. So the volume of this cuboid that has these three dimensions will be equal to 288. In the next question, we have the volume, we have the length, the width, but we do not have the height. So remember that height is equal to volume over length times width. So we first need to multiply length times width. 5 times 4, which is 20. Then now we take the volume, which is 40. We divide by the product of length and width, which is 20. So 40 divided by 20 is equal to 2. So the height of this cuboid is 2. Next, we look for the volume. We look for the width. So we want the width given the volume, which is 100. The length is 10 and the height is 2. So we first get the product of length and height. 10 times 2, which is 20. Then now we have 100, which is the volume, divided by 20 to give you 5. Okay? 100 divided by 20, which is equal to 5. Then we have the volume now, the length, the width, and we are looking for the height. So we use the formula, height is equal to volume over length times width. So the volume is 200, the length is 25, and the width is 2. So 25 times 2 is 50. Then 200 divided by 50 is equal to 4. So it doesn't matter what you have been given in this formula, as long as you have three quantities, either 1, 2, 3, or 1, 2, 3, or 1, 2, 3, or 1, 2, 3. You can always determine the fourth quantity. Now we are going to look at how to determine the volume of a cube. So volume of a cube. A cube is not very different from a cuboid. In fact, the only difference is that the faces that make up a cube are made up of squares. So a cube still has 6 faces and it is made up of equal squares. That means that all the faces, all the sides of a cube are equal. So if you draw a cube, it's the same as drawing a cuboid, but then you must make sure that all the sides appear to be equal, or rather are actually equal. So this is a cube, okay? So this side is equal to this side and is equal to this side. So if you want to determine the volume of a cube, then it will be side times side times side, which is equal to side cubed, all right? Now, if we do an example, if you have this cube with dimensions of 4 centimeters by 4 centimeters by 4 centimeters, then the volume will be equal to 4 cubed. Remember that 4 cubed is equal to 4 times 4 times 4. Now 4 times 4 is 16, 16 times 4 is 64. And since the units are centimeters here, then we will have centimeters cubed. So a cube is very similar to a cuboid. The only difference is that a cuboid has faces that are made up of rectangles, but a cube has faces that are made up of squares. And since we know that equal squares, since we know that the sides of a square are equal, then all the sides of the cuboid will also be equal. So finally, we are going to look at how do we determine the volume of a cylinder. So now we are going to look at how do we calculate the volume of a cylinder. Do you know how a cylinder looks like? Are you able to spot an object near you that is cylindrical in shape? A very common object that we have in our homes that could be cylindrical is a glass, a cup, And even this marker is cylindrical in shape. So if you look at it, you notice that the bottom part and the top part are circular. And then the segment joining the two circles is curved, okay? So whenever you want to determine the space that is occupied by this marker, you would have to take the area of the circle and then you multiply by how high the marker goes. All right, the area of the circle times the height of the marker. So if we draw a cylinder here, all right, and then like that. So like you can see, we have two circles and then a curved surface. Now the circle has a radius and then we have the height of the whole cylinder. So when you want to determine the area or rather the volume that is occupied by this cylinder, you will take the area of the bottom surface, which is circular, and we know that the area of a circle is given by pi r squared, and then you multiply by how high the cylinder goes. So you multiply by height. Now, I know that this is not the first time we are coming across pi. Pi is the same as 22/7 or 3.142. In some questions, the question will specify the value that you will use. If the value is not specified, you can use any of the two values. They represent the same number. So let us assume that our cylinder here has a volume or rather has a radius of 7 centimeters and then it has a height of 20 centimeters. So how would we determine the volume of this cylinder? So like we have highlighted, the formula is volume equals pi r squared times the height. Pi is 22/7 times the radius, which is 7, times the radius again, which is 7, times the height, which is 20. So the 7 cancels out with the other 7. So now we have 22 times 7 times 20, which is equal to 3080 centimeters cubed. Remember, we are calculating volume. So since the radius was in centimeters and the height was in centimeters, then the volume will be in centimeters cubed. What I need you to remember is that whether you are dealing with a cylinder that is closed or one that is open, the formula will remain the same because the amount of space occupied by the cylinder does not change based on whether it is open or closed. What changes is the area. So I know that you can remember what we discussed when determining the surface area of a cylinder, but for the volume, the formula remains the same. So now we are going to look at if you have a volume and then you have maybe the radius, how do you determine the height? So I want us to form our own question here where the volume of a particular cylinder is equal to 1540 centimeters cubed, and then the radius is 7 centimeters, and maybe the question is what is the height of this cylinder. So basically you just apply this in the formula. So we know that volume is equal to pi r squared height. So volume is 1540, which is equal to 22/7 times the radius, which is 7, times 7 times the height. All right. So if we cancel out this by 7 by 7 then 22 times 7 is 154. So 1540 will be equal to 154 times the height. So we divide both sides by 154, and this 154 cancels out, and then by 154 1 by 154 10. So the height of this cylinder will be equal to 10 centimeters. So it doesn't matter the quantity that is missing. All you have to do is to substitute the values given in the formula and then work out for what is missing. So now we have learned how to determine the volume of a cube, a cuboid, and then a cylinder. So we are going now to look at what is capacity and how is it related to volume. Capacity refers to, so when we talk about the capacity of a container, we are talking about the amount of liquid that that container can hold. Sometimes you go to the supermarket and you want to buy something like cooking oil, and sometimes you buy maybe cooking oil for 1 liter, 2 liters, 3 liters, and so on. So the 3 liters, the 2 liters refers to the capacity of the container which has the oil. Well, obviously there's usually some space left, to ensure that it doesn't spill and doesn't go bad. Same case to a soda. If you want to buy a soda, sometimes you're sent to the supermarket and you're told, come with 2 liters of soda. So you pick the container, the bottle that can hold 2 liters of soda, or maybe 4 containers, each holding 500 milliliters of soda. So when we talk about capacity of a container, we mean the amount of liquid that that container can hold. So capacity, the most commonly used unit of capacity is liters. So the unit of capacity is liters, and it is written as small l. So when you are told to get 2 liters of soda, I know in your mind right now you can already picture the bottle that holds 2 liters of soda. Now the other unit that is used is milliliters. Milliliters. Okay, so milliliters is written as ml. So if you want a soda that is 500 milliliters, you can already picture the bottle that holds 500 milliliters of soda or 500 milliliters of yogurt, and so on. So there's a relationship between milliliters and liters, where liters is bigger than milliliters. So 1 liter is equivalent to how many milliliters? 1 liter is equivalent to 1,000 milliliters. Okay, if you want 1 liter of soda, you can take 500 milliliters of soda and 500 milliliters of soda to make 1,000 milliliters of soda, and that would be equivalent to 1 liter. So this is a relationship that you must recall. Now remember that these liquids are put in containers, and these containers have their own volume, which is the amount of space that they occupy. So that means that capacity can be converted to volume, and volume can be converted to capacity. So what is the relationship? Now for us to remember this, we are going to construct a tank, and this tank is going to be 1 meter long, 1 meter wide, and 1 meter high. So this is 1 meter, and then 1 meter, and then this is 1 meter. Okay, so if you determine the volume of this tank, it will be 1 meter times 1 meter times 1 meter, which is equal to 1 meters cubed. Now if you decide to fill this tank with water, then you're going to take 1 liter of water, pour it into the tank, another liter, pour it into the tank until it is full. Now, by the time you fill it, you will realize that you will have used 1,000 liters to fill 1 meters cubed of a tank. So the relationship here is that 1 meters cubed, a volume of 1 meters cubed, can be filled using 1,000 liters. So this is the relationship that we are looking for. Okay? Now, if you make another tank, I want you to imagine your ruler, your 30 centimeter ruler, and then, or your 15 centimeter ruler. Imagine how small a centimeter is. A centimeter is very small, probably smaller than the size of your nail. So if you make another tank that is so small, okay, such that this tank is 1 centimeter by 1 centimeter by 1 centimeter, the volume of this tank will be 1 centimeter cubed. That's a very small tank. Now, if you fill it with water, it will be filled by just 1 milliliter, not liter. A liter of water is so much. So 1 milliliter. So we can say that the other relationship that we need to know is that 1 centimeters cubed is equal to 1 milliliter. Okay? 1 centimeters cubed is equal to 1 milliliter. The other one is that 1 meters cubed is equal to 1,000 liters. Now, is there a direct relationship between meters cubed and milliliters? So you can always create it, okay? You can always create it. From volume, we know that 1 meters cubed is equal to 1,000,000 centimeters cubed. And since 1 centimeters cubed is equal to 1 milliliter, then it means that 1,000,000 centimeters cubed is equal to 1,000,000 milliliter. Got that? Let me write that for you. So we are saying that 1 meters cubed is equal to 1,000,000 centimeters cubed. But a centimeters cubed is equal to a milliliter. So 1 meters cubed is also equal to 1,000,000 milliliter. So this is another relationship that we need to recall. Alright? That 1 meters cubed is equal to 1,000,000 milliliters. So now we are going to do a few questions on conversion. So now we are going to work out these 3 questions. We are going to convert 8 meters cubed to liters. So you need to first write the relationship between the two. So 1 meters cubed is equal to how many liters? Can you remember? It's equal to 1,000 liters. So what about 8 meters cubed? How many liters? So we cross multiply 8 times 1,000 divided by 1, which is equal to 8,000 liters. Okay? Next, we are converting 4,000 liters to meters cubed. So 1 meters cubed again is equal to 1,000 liters. What about 4,000 liters? If we cross multiply, we have 1 times 4,000 divided by 1,000. So the zeros cancel out, and then we'll be left with 4 liters. 4 meters cubed, because we were converting liters to meters cubed. Then yes, we are supposed to convert 1,700 milliliters to liters. So we know that 1 liter is equal to 1,000 milliliters. What about 1,700 milliliters? So we cross multiply 1 times 1,700 divided by 1,000. The 2 zeros will cancel out. 17 divided by 10 is equal to 1.7 liters. So that is how you convert between units of volume and capacity. So the two are used interchangeably, because volume refers to the amount of space occupied by a container and capacity refers to the amount of liquid that the same container can hold. So I want to believe that you have learned a lot in this lesson. Thank you for your attention. See you in the next lesson.